We're recording. Nice. Welcome back. So in this class, you know that there's an F word, right? That we use in this class. And factoring is that word. Very good. Very whoo. That was dangerous, kind of starting off the year with letting me have you. Some of y'all might have said farming, right? Right? But no, the F word in here is factoring. So it's probably, as I mentioned earlier, the most important skill that you can have getting out of algebra 2. Okay. Um, And what we do is we factor something until it's down to what we call a prime polynomial. A prime polynomial is going to be in the form like a times bx plus c, or it could be like an x squared plus d. This would be an irreducible. We talked about these irreducible square. The sum of two squares is irreducible. The difference of two squares can keep going. But for the most part, we're looking to get it down to a constant times some linear factor, like a line, mx plus b or bx plus c, whatever you want to call it. All right. Now, before we even do any of the methods that we learn, the first thing you do when you're trying to factor is what? What's the first rule? Well, if the terms aren't combined, you do want to combine like terms. But let's say the terms are combined. You can put them in descending order. That's possible. I would say the first rule is to actually look for a GCF. Okay? For any of the methods. Before you apply any of the methods, you look for a GCF, the greatest common factor, right? Now, also remember that factoring out is the same as dividing out. What's another word for dividing out? Factoring out, right? But when we divide it out, we don't just get rid of it, we put it out front, okay? So factoring is dividing. All right, so that's what this one says here. Factor the polynomial using the GCF. Even if the instructions weren't given to us, that would be the first thing we would do. We would notice there's how many terms? Three terms, good. And they have X's and Y's, so I don't think I'm going to bother shuffling the terms around to put it in any kind of order. I like this order. But I'm going to look for a common factor in each of the three terms. And since they have numbers and variables, I like to start with the numbers. So 8, 4, and 12. Is there a common factor in 8, 4, and 12? 4. So I'm going to divide out the 4 from all three of those, and I'm going to put it out front. Okay? Now let's look at x's. Is there a common factor of x? Any power of x's in all three of them? X to the first, right? So remember, we have to pull out for variables. For variables, we pull out the least power. Okay? You have to pull out the smallest power because that's the one that they all have in common. And they all have x to the first in common. All right, what about y? Any of them have any y's in common? They all have at least one y, so we'll pull out the smallest exponent, 1, 1, and 2, which is 1. Okay, so we pull out a 4xy, and then we put a parenthesis. And now we factor out, which remember is dividing out. So what we're really doing here, this is what we're doing off to the side on our mathematical workbench. We're taking 8x cubed y, which is what we started with, and we're dividing out a 4xy. That's really what we're doing. Now you can do this in your head, but this is actually what we're doing off to the side. I want to show you. So let's do the numbers first. What would 8 divided by 4 give us? 2. And what's x cubed divided by x to the first? X to the second, right? What does the rule say we do with the exponents when we're dividing in the bases? Subtract them. Good. And what happens with the y's? Just y?
No. 0y.
0y. Not 0y, but y to the 0, which is what? What's another name for y to the 0?
1.
1.
I
Yeah.
don't know.
Yeah. No, you do know. The y's, what do we say that happens to the y's? Do they cancel or divide out? Divide out. They divide out. And things always divide out to give you what number? 1. Things cancel to give you 0. Things divide out to give you 1. So, yeah, and it works. The rule works because 1 minus 1 is 0, and y to the 0 is 1. So we're just left with 2x squared. So I'm going to put a 2x squared right here. Now, could you do that in your head? Sure. Yeah. In fact, let's do the next one in our head. When I factor a 4 out of a negative 4, I'm left with the negative 1. What am I left when I factor an x out of an x? A 1. What am I left when I factor or divide out a y out divided by y? 1. So what am I left in the middle term? Minus 1, actually, right? But yeah, minus 1. We factor the whole thing out. And then on the next one, what's 12 divided by 4? 3. What's x divided by x? 1. What's y squared divided by y? Y. Close parenthesis.
Wait, why did the x go away?
In the middle term? Because it was minus 4xy divided by 4xy. And so it's x to the first divided by x to the first. They divide out.
If it's equal to 1, why don't we like write it on the... Wait,
I wrote a 1 right there.
no, like the x and the y. Like if
Well,
it cancel out for like,
if you want to put x to the 0, y to the 0,
oh, I can
you can. If you want to put x to the 0, y to the 0 as an intermediate step, you can. But then you're going to have to come back on the next line and realize that what's anything to the 0 power?
1.
1. Yeah.
I was saying like, why don't you put 1? Like,
Why don't I put 1? What? Where?
if they're equal to 1, then why don't you write 1? You know what I mean?
I did put a 1. You have a 1 too. We both have a 1. Where do you want to put another 1?
Like for these.
Yeah. What about it? I wrote a 1 right here. See? I wrote a 1. Show me where you want to put. Okay, then where would you want to put another 1?
Like for this y that cancels out.
Yeah? It divides out.
Yeah, it divides out to 1.
Uh-huh.
But why don't you put a 1?
Oh, I see. I see. Oh, okay. Because the y's. Here's the question. Everyone listen up. Good question. The y's divide out in the first one. You got y to the first divided by y. Why don't you put a 1? You certainly can. You certainly can. And for inventory purposes, it wouldn't be bad to put a 1 there because then you could be like, oh, the y's divided out left me with the 1. But the reason we don't need the 1 is because on the next step, when I simplified, what's anything times 1? The same itself, right? So because 2x squared times 1 is just 2x squared, we don't have to worry about showing the factors of 1. Okay? Now, why do I need to put the 1 in the middle if the whole thing divides out? I need to show it there, right? Because without it, it would be gone, right? It would be gone. There's not another factor there to take its place. So when 1 is the only factor, I have to put a 1. Now, let's say I factored this out, or I divided out the 4xy all the way through, and I get this line right here, and I'm not quite sure if it's correct. Is there a way to check ourselves before we wreck ourselves? I can multiply it back in, right? Yeah. So let me box this up as my final answer. And then let me go ahead and check. So I'm going to write underneath here, this is a check. I'm just going to redistribute. What's 4xy times 2x squared? Well, that's going to be 8x cubed and then y. That's my term. And then if I distribute to the next, anything times 1 is itself, but now becomes minus 4xy. And then plus 4 times 3 is 12xy squared. And that's what I get. And then I compare that to this, and what do I notice? They're the same. So what does that indicate about us? We're right. We're awesome. Yeah. So you can always check yourself when you're factoring by remultiplying on the back end of it. And then if you troubleshoot, like, ooh, man, it's close, but I don't have it exactly, I messed up on the middle. You know what the most common mistake students make is? I'll tell you this. I noticed this from experience, is when the terms divide out, instead of putting a 1 there, guess what they tend to put? They put nothing. They leave it as a 0. And now if you check yourself and you distribute back through, what's going to happen? There's not a placeholder there for that middle term, and you don't even generate it. You're like, uh-oh, I should have had a placeholder there. That was a 1, right? So if you just want to check yourself mentally, you don't actually have to do it. But if you want to check yourself mentally as you go, right, factor it out and then remultiply, make sure it's the same, and then go to the next term, so on and so forth. But that's the first rule of factoring. Look for the GCF. Now, once we factor that using the GCF, what you might want to do is look to see what's left over and see if it can get factored anymore. You don't just necessarily do it one time and then say, that must be it, right? The prime factorization might involve multiple steps. But 2x squared minus 1 plus 3y, that doesn't factor anymore because the x squared and the y are different variables. So There's not even a good reason to write that in descending order of variables. So we're done. That was the only purpose of this one, GCF. Sometimes that's the only thing we could do. All right. Questions on the first one? Let's call this number 1. Oops, with a stupid highlighter. First time this year I wrote with a stupid highlighter. Number 1. All right, let's go left to right. Let's do number 2. Factor the trinomial. Easy one. Easy one. All right, so I heard someone say combine like terms and writing in descending order. That makes sense here because there's only one variable. We don't have x's and y's. We just have powers of x's. So whenever you have single variables, write it in descending order. X squared, x to the first constant. Is it written in standard form? It looks good. Okay. Step 1, look for a common factor other than 1 or negative 1. Is there anything common in all three of them other than a 1 or a negative 1? No. Now this, remember, is a quadratic trinomial. A quadratic trinomial will get the double bubble factoring going. If there's no common factor, then set up your double bubble. Double bubble. Okay? And this is why this one's an easy one. The coefficient of x squared, the leading coefficient, is just a 1. That means that the first place in both of them has to be plain old x. And then remember how we figure out the rest of it? No. This is your target product, your TP, and positive 5 is your target sum. You want to find factors of your product that add up to your sum. What are some factors of negative 24? Do any of them add up to positive 5? 8 and 3. Very good. Does it matter which one's positive and which one's negative? Yeah, which one has to be positive? The 8, because your sum is positive, your larger of the two products has to be positive. And then this one's negative. Now, if you're not sure if this is right, is there a way to check?
Yes.
Yeah, how do we check it? What process do we call that? Foiling? Foiling, yeah. Or we could just do multiplication. Remember, I said foiling doesn't always work. It only works when you have a 2 by 2. Let's just try good old-fashioned factoring, okay? We'll take the x and we'll distribute it all the way through to both of them. So I get x times x is x squared minus 3 times x, and then I move to the next one. 8 times x is positive 8x. 8 times negative 3 is negative 24. And then we combine our two like terms, and we get positive 5x minus 24. And we compare it to what we started with, and is it the same? Yeah, it is. So that means that we're awesome. So if you check below your answer, it's a good idea to come back and put a box around your answer. Otherwise, I might think that the bottom line is where you ended up.
Would you put like that as your answer, or would you put like negative 8, 3?
No, that's if it's equal to 0 and I ask you to solve. Then you would say, okay, now x equals negative 8 and x equals 3. That's only if you're solving or you're finding the roots. We're not finding the roots, we're just factoring. So good question. Yeah, I don't set it equal to 0. This is actually where I stop. Now, of course, if you do it the other way, it could also be x minus 3 times x plus 8, couldn't it? What property of that allows those to both be the same? What property allows you to flip your factors around? Not the distributive. When you go from here to home and home to here, you're commuting back and forth, right? It's the commutative. The commutative property. Multiplication and addition are both commutative. Subtraction and division, not commutative. Okay, you can multiply in any order. All right, questions on factoring the trinomial? Easy one. Easy one. Too easy. That was insulting, sir. Give us another one. Okay. Factoring the trinomial, we'll call this number 3. Assess the problem first. I have 3 terms, right? 3 terms. There's only one variable x. Is it written in standard form? In descending order? Yes. Okay, so there's no like housekeeping to do. I want to factor it. I am now ready to factor this dude. The first rule of factoring is always, always, never, not always to what? Look for a greatest common factor. You're not guaranteed to have one other than 1 or negative 1, but you always look first. Is there a common factor in these three terms? Yes, what is it?
3.
3. There's no variable, but there's a 3. So I will divide the 3 out from each of the terms, and I'll put the 3 that I divide out in the front. What's 3x squared divided by 3? X squared. What's minus 3x divided by 3? X. What's minus 36 divided by 3? 12. There it is. Now, like I said in the beginning, you don't just factor something out and be like, I must be done, right? You factor and you keep chipping away at it until you get down to things that look like this, okay? Irreducible linear. So now I focus on this piece right here and I ask myself, self, does that factor anymore? Well, let's see. We'll try it. We're going to bring the 3 down. Stupid highlighter. We're going to bring the 3 down because it's already one of the factors. And then that cubic trinomial might double bubble. Now, inside the parentheses, the leading coefficient is 1. So this is another one of the easy varieties, right? It's got to be an x and an x. And now I just look for factors of negative 12 that add up to negative 1. Target sum, target product. Negative 12 factors that add up to negative 1. 6 and 2, right? No. No, 6 and 2 give me a 4 or an 8. 3 and 4. Which one has to be negative? The 4, because it's larger, and then the 3, because the sum is negative. There you go. And if you're not sure, can you FOIL that out? Yes. At some point, you're going to get so good, you're going to be sure, and you're not going to have to check, or you could check in your head. Like I always check this in my head. I just do the inner and outer and add them together. 3x on the inside minus 4x on the outside. I add them together. It gives me negative x. That's what I want. So there it is. That's your final answer. Now, if you're not checking or doing anything else underneath here, you don't even need to box it. Your bottom line is considered your answer. Now, do I want to say x equals negative 3 and x equals 4? Do I keep going and do that?
No.
No. That's only if the instructions say to solve when it's equal to 0, or if it asks you to find the roots of the x-intercepts or the zeros. Okay? It didn't ask us to do that, so we're just factoring. All right, questions on number 3? Make sure your phones are away. Don't be distracted. I don't have my phone out. I spent a lot of time on Twitter over the break. Too much time. Unhealthy amount of time. It's called X now, isn't it? Yeah. Hard to get used to. All right. Number 4. Factor the trinomial. Harder one. Harder one. Does that influence you when you read that? You're like, oh my gosh, now I'm starting to get nervous. There's only one variable, x. Is it written in standard form? Descending order? Yes. Okay. So now, no housekeeping, no rearranging the terms, no combining like terms. I'm ready to factor it. What's step 1? Greatest common factor. Is there a GCF here? No. Other than 1 or negative 1, there's not. Now, this is a harder one because of what? The 3. 3. That's not a 1, is it? So I taught y'all a couple ways to do this. The first way is just to double bubble it, which is by brute force. We'll call this the brute force, which is really just guess and check. Now, the nice thing about 3 is it's prime. There's only one way to factor 3, right? And that's 3 times 1. If that were a 4, it could have been a 2 times 2 or a 4 times 1. So when the leading number is a prime number, it's quote-unquote harder, but it's not the hardest variety. So you could automatically put one of them as 3x and the other one is x. It doesn't matter which one is which at this point. But now here's the deal. Now I got to look for factors of negative 8 that when I combine them with the 3, give me negative 2. And unfortunately, negative 8 has a couple of ways to factor, right? So watch. This could either be a negative 8 and a positive 1. It could be a positive 8 and a negative 1. Or it could be a positive 4 and a negative 2. Or a negative 4 and a positive 2. There's only 4 possibilities, right? Would you agree? The brute force method just says try them all out. Well, I know that the FOIL part, the L in the FOIL, it's going to work. The product of all of those numbers on the left and all those numbers on the right gives me -8. The way I'm going to see if it works, remember, is just taking the sum of the inner and outer to see if it equals -2. Let's just go down the line and see. Let's try the first one. The inside is -8x. The outside is going to be 3x. What's -8x plus 3x? Is it -2x? No, it's -5x, right? So that doesn't work. So sorry, it's not going to be this one. Boom. What about the 8 minus 1? That's going to be 8x minus 3x. No, that's positive 5x. That doesn't work either. What about the 4 and the 2? The 4 on the inside gives me a 4x. The -2 on the outside gives me a -6. A 4x minus 6x, is that -2? That is -2. So there it is. It's not going to be the -4 positive 2. It's the positive 4 -2. So that's just kind of a way to go about it. Now you can write your answer confidently, 3x plus 4, x minus 2. Brute force method, guess and check. That's how I learned to do it. It's a little tedious, but it works. You can just try it out. There's only going to be a limited number of possibilities, and if I give you something that's factorable, you know one of them is going to work, right? So you don't have to sit there and say, uh-oh, what if none of them work? If you're supposed to be factoring it, it's going to be factorable. Or the other way to do it, this is called split the middle term. Or sometimes what I call target product, target sum. So here's what we need to do. Off to the side, we need to get our target product. Your target product is always going to be the product of the first and the last, the leading coefficient and the constant. What is 3 times -8? -24. Okay? That's why when that number in the front is just a 1, your target product is just your constant, because 1 times your constant is just your constant. But whenever it's something more than a 1, you got to multiply it by that number. So our target product is -4. Our target sum is still going to be -2. That doesn't change. Okay? Now we can kind of reframe the problem. Instead of looking for the combination of 2 different factors, the 3 and the 8, we just look at 24. Okay? What are some factors of -24 that add up to -2? 6 and 4? Let's see. A 6 and a 4? Which one has to be positive? Which one has to be negative? Does it matter? Yeah, if the sum has to be negative, it has to be a -6 and a positive 4. Is that what you said? I think so, right? Because that's -6 plus 4, which is -2. Did we find them? We found them, okay? So here's what it involves, though. It involves splitting the middle term. So now we're going to have 3x squared, and we're going to have -8. That's still going to stay the same. But your -2x gets written now as -6x plus 4x. There's lots of things that add together to give us -2, but we're specifically using -6 and 4. Because that's the product gives us -24. Everyone see what I did there? All right. Now, once you have 4 terms, now you're going to factor by grouping. This is what happens when you have 4 terms. You factor by grouping. So we're going to take the first 2 together, and we're going to take the last 2 together, and we're going to put a plus sign in between there. You always group the first 2 and the last 2, and you put a plus sign in between them. Now, remember factor by grouping. That's his own special skill. Factor by grouping involves looking for GCFs in your pairs. Looking for your GCFs in your pairs. What is common in 3x squared minus 6x? Is there a number that's common? There's a 3 that's common, and there's also an x that's common. So we're going to factor out the 3x from those two guys. What's 3x squared divided by 3x? X. And then minus, what's 6x divided by 3x? 2. You get x minus 2. And then you do it in the next one. You're looking for common factors in 4x and negative 8. What's common in 4x and negative 8? 4. So I'm going to say plus 4 parentheses. And then I factor out. What's 4x divided by 4? X. What's negative 8 divided by 4? Negative 2. Yeah. And now you're almost there. This is how factor by grouping will always work. You'll always end up with a common binomial factor. It'll be common in both of those. So on the next line, if I pull that common binomial factor out, x minus 2, what am I left with? I'm left with a 3x in the first term, and I'm left with a plus 4 in the second term. And is x minus 2 times 3x plus 4 the same as 3x plus 4 times x minus 2? Yeah, what property allows us to say those are the same? Commutative. Very good. So factor by grouping is it's a formal way to do it. It takes a little bit of the guesswork out of it. You still got to find those two numbers, in this case negative 6 and 4, but you're working with a single number, negative 24, instead of combinations of 3 and negative 8. So I don't care how you do it, but make sure that you have one of them figured out. Negative 24 is your target product. It's the product of the first and the last. Okay? Yeah, it's a sub 2 times a sub o. If you remember from the polynomial days, it's your leading coefficient times your constant. The first times the last. That's where I got negative 24. That's important because that's how I started the whole problem. So if you don't know how to get that number, glad you asked. Any other questions on this method? Harder one. This is why I like the guess and check method. You can almost guess and check in your head, but even if you have to write out the guess and check by listing your factor pairs and crossing them off as you try them out, it's good for you to have the flexibility of mind to just do inner and outer. Product of the inner, product of the outer, add them together. Does it equal negative 2x, yes or no? And then move on to the next. You only got 4 options here. That would be a lot harder if the 3 in the front were not prime. Then you have a lot more combinations to try out. Okay. All right, let's move across here. Number 4, well, that was across, so let's come down here. This is number 5. Factor the polynomial as a difference of squares. Okay. X squared minus 64. That's a single variable, x, and there's no x term. See that? There's just an x squared term. We're missing the linear term. So it is written in standard form. But if you're ever missing the linear term, and this right here is a minus, right, then this is a difference of 2 squares. And remember, the difference of 2 squares double bubbles as conjugate pairs. Conjugate pairs. Remember, the only difference between conjugate pairs is one of them is plus and one of them is minus. One of them is plus and one of them is minus. Now, how do we get the two numbers or variables that go in front of there? We take the square root. What's the square root of x squared? X. And then what's the square root of 64? 8. So it's x plus 8, x minus 8, or of course it could be x minus 8, x plus 8. Either one. Difference of squares. It's a special product. So you want to be on the lookout for that. Now, just for kicks and giggles, what if this were x squared plus 64? Would it factor the same way? Obviously not, because you'd get x squared minus 64. This right here is what we call an irreducible prime. It's an irreducible quadratic prime. It would stay like that, yeah. This is the sum of 2 squares, which is not factorable. Oh, by the way, on x squared minus 64, once we factor it, do you want to go one more line and say x equals plus or minus 8? Yeah? No, why not? It's not equal to 0, is it? You only do this if you only do that if it's equal to 0, or it says to find the x-intercepts slash roots slash zeros. If it just says to factor it and there's no equation, you just factor it. X plus 8, x minus 8, and you move on. All right. Factor the polynomial as a perfect square trinomial. You don't even have to know that something is a perfect square trinomial before you realize it's a perfect square trinomial. You could just do what we did up here on the easy one. You could just say, okay, it's a trinomial, it's quadratic, it's written in standard form. Is there a common factor? Anything common other than 1 or negative 1? No, the first one doesn't have a 3 in it. No. So there's nothing common. There's nothing common. So this one could be one of them double bubble dudes, right? And if it were a double bubble dude, since it's a 1 in front, it's going to be an easy double bubble one, right? X and X. And now it's your target product, target sum. Since it's a 1 in the front, your target product is just 9. 1 times 9 is 9, right? You could still say your target product is always the first times the last, but when the front is just a 1, it's just the last. So what are some factors of 9 that add up to negative 6? 3 and 3. Are they both positive or both negative? They're both negative. Negative 3x minus 3x is negative 6x, and negative 3 times negative 3 is positive 9. I didn't have to know there was a perfect square trinomial, but now that I get down here, I'm like, hey, x minus 3 and x minus 3, those are the same, right? So that's the same as x minus 3 to what power? Second power, the tooth power. Very good. And now you could say, oh, that's a perfect square trinomial. That's a perfect square trinomial. And if you wanted to see if you were right, you could either do square multiply double square, or write it as x minus 3 times x minus 3 and FOIL it out. So that's just kind of a review of the easy one up there. Easy trinomial, example number 2. But then realizing after the fact on the back end that you had nice factors, repeated factors. All right, that was number, I didn't label it, but that's number 6. All right, questions so far? So far, so good? All right, last one, number 7. Factor the polynomial by grouping. I wish they wouldn't tell me how to do it. That kind of takes half the fun out of it, doesn't it? Man. All right, let's take a look at it. How many terms do you see? 4. They only have a single variable of x, which most of the time they're going to have just a single variable x. Is it written in standard form, descending order? It is. Okay, so whoever said that in the beginning, combine like terms, write it in descending order. That's good. That's kind of like setting the table. Now we're ready to factor. The first rule of factoring is what? To panic?
Yeah.
No. Common factor. Is there a common factor?
No.
Now, other than 1 or negative 1, there's not, right? There's not. There's almost a 2, right? But the second term is a 3, not a factor of 2. So, and there's no x in all of them. So there's no GCF. Well, we look for it first. Don't forget to look for it first. So whenever you have 4 terms, how do we do it? You have to know it's by grouping. Anytime you have 4 terms, you factor by grouping. So you group the first 2 together, you group the second 2 together, and you squeeze a plus sign in between there. Very, very important that you squeeze the plus sign in between there. Otherwise, you turn it into a product of 2 things instead of still the sum of 4 things. Okay? I will take off if I don't see the plus sign squeezed in between there. And once you have it grouped, then you look for GCF. Okay, let me just do what Harley did. Harley did not put the parenthesis where I put my parenthesis of the third one. He put the parenthesis right here. Is that okay? That is okay. Okay? But I don't tend to do that. You know why? Because if this were a minus sign, could I just put the parenthesis like that? No, because then I'd have to factor the negative out. And I could factor it out and then make that a plus sign like that, if I know what I'm doing. But it would be better to do this and put a plus sign in between there. So you got to be careful. If that's a minus sign, you can't just do that little Harley trick. We'll call it the Harley trick. So what I'll do is I'll just get in the habit of doing it the same way every time. I'll put the parenthesis outside the plus sign and add a plus sign right there. That way, if it is a minus sign, I'm covered. And you would factor out the negative from both of them. All right, now we look for a GCF. What's the GCF in the first two terms? X squared. So I divide it out. What's 4x cubed divided by x squared? 4x. Good. And the next one, I get a minus sign. What's 3x squared divided by x squared? 3. What happens to the x squareds? No!
1.
They don't cancel out. They what? Divide out. 1. They divide out to give you 1. I got you, Caden. They divide out. They divide out. Okay. Plus, what's common in the next two? Positive 2? Yeah, 2. And when I factor it out, what's 8x divided by 2? 4x. And then minus, what's 6 divided by 2? 3. Now, when you factor by grouping, this is your checkpoint. You should get a common binomial factor appearing in both of your terms. If that's not happening, something went wrong up above. Go back and check. The next step then involves factoring that binomial factor out. And what are we left with in the first term? Well, when I factor the 4x minus 3 out of this, what am I left with? X squared. When I factor the 4x minus 3 out of that term, what am I left with? Plus 2. Yeah.
Where'd you get that?
The 2 is the common factor of the 8x and the 6.
Oh, I didn't know you had
Okay, now we're not done yet because I still see a quadratic term in there, right? Okay, so we look at x squared plus 2. Does that factor?
No.
The sum of two squares is what? Not factorable. It's not factorable. So this dude right here, this guy is prime. So that's your final answer. 4x minus 3 times x squared minus 2. Now, if that were x squared minus 4, or even x squared minus 2, you could still factor it as x minus the square root of 2, x plus the square root of 2. It would factor into two conjugate pairs. Because it's the sum of two squares, he's prime. And so there's your whole factorization. All right, so that pretty much summarizes all of the factoring skills that we've learned up to date. Starting tomorrow in 8.3, we're going to learn how to factor with multiple steps, which we kind of did. If you do the splitting the middle term, like I told you up here, it's multiple steps. We're also going to learn how to factor cubics. Yay, cubics, x to the third powers. Okay, that's all I got. So if you want to now do the HWQ that is associated with this, I activated it at the beginning of class. It's ready to go. Any questions? Yes.